In this question, there is a projectile motion. At some point of the projectile motion, the object is having a velocity u at an angle theta with the horizontal. We need to find out after how much time will its velocity vector make an angle perpendicular to the initial velocity vector at point A. So for solving this question, let us find out the general velocity vector after time t. For x direction, we know that in a parabolic path in projectile motion, the x component of velocity is always the same. So the x component of velocity after time t will be u cos theta only. This can be written as u cos theta I cap. We take this perpendicular direction as j cap. For y direction motion, the initial velocity was u sin theta j cap, acceleration was minus g j cap, time was t. So the final velocity vector can be written as u sin theta minus gt j cap. So the total final velocity vector including the two components becomes u cos theta I cap plus u sin theta minus gt j cap. Now we need the initial velocity vector was u cos theta I cap plus u sin theta j cap. Now we need to make this time equal to the time when the velocity vector becomes perpendicular to the initial velocity vector. So what we need to do is that we make the dot product of these two vectors to be 0. That is v final vector dot v initial vector equal to 0, because v final vector is the vector at the time when the velocity vector becomes perpendicular to the v initial vector. So while doing the dot product to be 0, we get the equation u square cos square theta plus u square sin square theta minus gt u sin theta equal to 0. This can be written as u square is equal to gt u sin theta. Therefore we get the time as u square upon u gets cancelled, u upon g sin theta. So final answer stands as u upon g sin theta is the time after which the velocity vector becomes perpendicular to the original vector.